Okay, so we're going to take a look at dictionaries and structures. Now, these are two different data types that we use when we want to store information in different ways. It's actually very useful in more complex logic, but even in simple logic, it's very helpful. It helps us stay organized and it helps us do less work with node graphs, like use less nodes to get our tasks done. And what I mean by that is, let's take a look at this example. So I have these four enemies here, and each enemy, if I click on them, you'll see that they have two custom variables. One is prefab ID and one is kill reward. And so prefab ID is just the prefab of the entity, and the kill reward is how much reward the player gets for killing it. For the treasure hoarder, the kill reward is 2. For the hilichurl, the kill reward is also 2. And for the milichurl, it's 3. Okay? So how I have it set up is that if I kill 3 unique enemies, and this is important, if I kill 3 unique enemies and their total kill reward sums up to 6 or more, then the player will win. Otherwise, the player is just going to get a complete status. So for example here, if I were to kill the slime for 1 point, and then the treasure hoarder for 2 and the hilichurl for 2, I'm going to get a total of 5 points. And you're going to see that it comes up as complete. And if I retry the challenge, and let's say I kill the milichurl for 3 points, and then the hilichurl for 2 points, and then the slime for 1 point, so that's going to be 6 points, and then we're going to get a victory screen. Okay, so this is what we're trying to do. I'm going to show you guys how to do this using dictionaries, but before I do that, obviously I want to explain what dictionaries are. So I just have a little canvas here that I'm going to draw on and explain what dictionaries are for those who just don't know what they are and how they work. Alright, so here's an example of what dictionaries are. A dictionary is basically two lists, right? We have a list that are just keys, and we have a list of values. So for this example, I'm just going over a literal dictionary, right? This because dictionaries in real life are basically what dictionaries are in computer science, in programming, and in this case in Miliastra. So if you ever wanted to find out the meaning of a word, you go to a dictionary, you search up the word, and then you look at its value, its definition, right? Now you're never going to have the same word appear twice. And that's one of the key points about what dictionaries are, is that you can't have the same value as a key more than once. Okay, so you're never going to have one car and then another car, and that's going to point to another meaning. Instead, you're going to have just car. It's going to point to a meaning. But if you have a word like fall, for example, that has multiple meanings, you're still going to have just one key, but it's going to map to multiple values. So in this case, it has 3 definitions that it maps to. There's actually way more, but just for example's sake, you get the idea. Now, the thing is with dictionaries, the key and the value have to have a specific type, and they can't deviate from it. So if you have a key of strings, which these are, right? These are strings. You can't have an integer like the number 2 in here and have it map to a value. It has to be a string. And similarly with values, you can't have string values and then have an integer or something else in here. So then how does fall map to multiple values? So it actually maps a string to a string list. Okay, it's just that in this case, this list has 1 element in it, whereas this list has 3 elements in it. So that's what's actually happening here. A dictionary is just a dictionary of strings, which maps to a list of strings. So you might be asking yourself, why do we have to use a dictionary? Why can't we just have a list of strings and then we have a list of lists of strings, right? So why can't we just have it this way? So there's 2 main reasons why we want to use a dictionary. The first reason is actually because every key is unique. We want to make sure that we're consistent and that our lists never have the same key, so that we're confident that if we want to search the dictionary, it's always going to have one result and it's going to map to one specific value. Because the problem with using a list is, let's say you do want to search the value of fall, right? You want to search its definition. So then what do you do if you have a list? Well, you might have 2 falls in here, or maybe even 3 falls that each map to their own definitions. There are different definitions of fall. And so when you're looking through a list, you have to find every single fall item individually, and they might be in different spots, right? It might be like this fall is in index 2, and this fall is in index 6, and this fall is in index 17. And so you kind of have to like either keep track of where all the falls are, or you have to just go through the entire list and find them. And so the beauty of dictionaries is that you know that there's going to be one key for that specific thing that you're looking for, and it's going to map to whatever you need it to map to. So it's kind of like this data structure that we have that's very organized and very reliable. The other reason why we use dictionaries, and this is kind of the most important reason, is because it's very simple and it doesn't require loops. So if you've ever worked with lists before, so for example, let me just draw out an example. Let's say I have a list with 4 items in it, and let's say I want to find out where the number 3 is. Okay, so I have this list of numbers. It's in no particular order, and I want to find out where the number 3 is, right? So okay, so I'm going to go through the list and I'm going to iterate. I'm going to check if this is a number 3, it's not. And then I'm going to check if this is a number 3 and this, okay, here we go, it's a number 3, right? So we found it. But let's say, for example, this list doesn't have 4 items, but 400 or 4,000 items in the list. And so we have to go through every single element in the list until we find our number. So if these numbers were not in order, like for example, if instead the order was this, and we were trying to find the number 2, well then we would have to go through every single item in the list, and then we'd find number 2 at the end. And so it's a lot of computation, it's a lot of iterations in the loop. It takes up a lot of time, it takes up a lot of resources. So it's much easier if instead we use the dictionary. Now, obviously, if our list of numbers can repeat itself, right? So for example, if I can have the number 2 in here and the number 2 in here, if this is allowed, and if this is what we want, then a dictionary is not the way to go, because obviously dictionaries can only store one key that's unique, right? 2 cannot repeat itself multiple times. So if you're required to have the number 2 in this case appear more than once, then a list is kind of your way to go. But in a case where you don't need to have repeating values, like in an actual dictionary, right, where we just want to see all the definitions for one word, then we use a dictionary. Okay, so it has its practical use cases, and it also is very efficient and it's very easy to work with. But if you just want to have one unique thing to look up and find its value, then a dictionary is the way to go. So remember my example earlier where I needed to kill 3 unique enemies, and I added up their kill rewards to see if it's greater or equal to 6, and then I'm going to let the player win. Otherwise, I'm going to just have them complete the round, right? So this is basically the node graph for it. I have it here called log creation kills. And on my player, I have a custom variable, which is a dictionary that maps a prefab ID to an integer, and I call it prefab ID to kill reward. So basically this dictionary is going to store a prefab ID and it's going to map it to a kill reward, right? And so remember that the enemies in my scene all have prefab IDs as custom variables. So essentially what I'm doing is when I kill an enemy, I'm going to take that prefab ID, I'm going to put it in a dictionary as a key, and then I'm going to map it to the kill reward that I get from them. Because every prefab ID is going to be different for each type of entity, I know that every entry in my dictionary means that I have a unique enemy that I killed, and every single entry in that dictionary is going to map to a kill reward, so I know that that kill reward pertains to that specific prefab ID, that specific enemy. So if we just take a look at what's happening here, when the entity is destroyed, I'm getting the player which killed the entity, I'm getting this dictionary, which is a custom variable, right, that prefab ID to kill reward dictionary, and I'm getting the prefab ID and the kill reward of the thing that died, and I'm adding it to this dictionary. Using the set or add key value pairs to dictionary node, you can pass in a dictionary, you can pass in a key and a value. So if you see here, the key is the prefab ID and the value is the kill reward. When you're working with dictionaries inside of the node graph, you have to make sure you click on this little icon here and you set what type the dictionary is. So as an example, just to show it to you, if you click on this gear icon and then select dictionary, you'll then see that this dictionary icon appears and you can click on what type your key is. So in my case, it's going to be a prefab ID and it's going to map to an integer, which is the kill reward. So every time an entity is destroyed, I check if it's a creation, right? So it's basically going to be an enemy, and it's going to get the prefab ID and the kill reward. It's going to add it to the dictionary that's on my player. And then I query the dictionary's length. If the dictionary's length is 3, I know that I killed 3 unique enemies because every key in the dictionary has to be unique. So that means there are 3 unique prefab IDs in the dictionary. And then if this is true, then I get the list of values from the dictionary, I iterate through them, and I just add them to a local variable to get their result. And in here, I check to make sure that the sum total of the variable that I was adding all these kill rewards to is greater or equal to 6. If it's true, I'll set the player settlement status to victory and settle the stage. Otherwise, I'll just settle the stage like normal, and they're going to get a complete status. As an example here, I'm going to show you what happens in the log whenever I kill these enemies. So if we take a look, I killed 3 enemies, and each time, let's click into the first one. What happened is I killed the hilichurl first, and you can see here that when I get the custom variable, and if we just follow this custom variable that's on the player, the dictionary, you can see that it starts off as empty, and then after I set the key, you can see that the output turns into here, where it has this key of this prefab ID and this value of 2. Now if I click into this node graph, which is the second time I killed an enemy, and that was the Miliastra, you see that if I click into here now, you see that it has this prefab ID key from earlier when I killed the Miliastra with its value of 2. And then I killed the Miliastra, and after I set the values of the prefab ID and the kill reward of the Miliastra, you see that the output, it turns into another entry where it's the key of the Miliastra and the value of 3. And lastly, when I kill the slime at the end, you see if I click on the dictionary again, you see that initially it has the values of the Miliastra and the Miliastra, and then when I kill the slime, it adds in this key with the value of 1, which is the kill reward of the slime, right? 1. So afterwards, it goes ahead and it sees that, okay, there are 3 entries in the list now, right? We have 1, 2, 3 entries. It says that, yep, that's true. And then it iterates through each value in the dictionary. It adds it to this local variable with an addition, and then it checks it, and then it sets my player status to victory. Now, I just wanted to go over dictionaries really quick because I wanted to explain how you actually do things with dictionaries. So we have here these 4 main nodes that you'll be using. There's actually a lot more nodes that have dictionary related things in here, like a lot more. For the most part, they're very self-explanatory, and if you know how to use these 4 nodes, you should be able to figure out the rest. I just don't want to go through every single option because it's going to take a while. But yeah, you can also assemble your own dictionary inside the node graph if you wanted to. You would just have to specify what type your keys are and what type your values are. Aside from that, if we just take a look at what these nodes are here, these are your main nodes. We have clear dictionary, which takes in a dictionary and gets rid of all the keys and all the values. So you're essentially starting with an empty one right after. Then we have set or add key value pairs to dictionary. Now the reason it says set or add is, remember, dictionaries have a specific unique key, right? You can't have the same key more than once. So if you try to pass in a key value pair, and let's say, for example, you try to pass in a key of 2 and the dictionary has already a key of 2, then it's going to replace that key's value with the new value. So in my case here, when I kill an enemy that has a prefab ID that already exists in the dictionary, it's just going to replace it. It's not going to change anything, right? And let's say, for example, that entity has the same prefab ID, but for whatever reason, the kill reward is different. So then it's going to use the same prefab ID, but it's going to update the kill reward, which is the value. It's going to change it from like 2 to 3. So that's something that you should be aware of. You can also query a dictionary. This is how you actually get a value from a dictionary. So if I pass in a prefab ID, it's going to give me the value, which is the kill reward. And then we can check if a dictionary contains a specific key. This is useful if you want to do some logic only if, for example, a prefab ID exists in the dictionary. Otherwise, I don't want to do anything, right? So you can pass in a key and it's just going to give you a true or false, yes or no. So, okay, dictionaries are really cool. They're really useful. But what if you need some more complex data? So I'm going to go over structures next. Structures is a little more complicated, but they're also very useful when you want to combine multiple different data types into one data type. So if you go here in the top left corner and you click on Advanced Data Management, I actually have a lot of things here already. But what I'm going to do is I'm going to click on Create Structure, and I'm going to give it a name like, for example, Enemy Data. If we click into enemy data, you see that it's empty, but it has a configuration ID. And in here, what you can do is you can specify all the different types of data that you need to represent your enemy. So let me give you an example. Let's say, for example, this Miliastra, it has 2 custom variables on it for prefab ID and kill reward, right? Let's say I wanted to add a name to this Miliastra. We're going to call him Bob. And let's say I wanted to add another integer or even a floating point number, just to make this a little more complicated. And we're going to call this EXP on kill, and this is going to be whatever, 12. And I have some fancy logic. I don't actually have it, but this is just as an example. And I have all this logic to check for what enemy name I killed and how much XP to give the player and what kill reward I have to give the player and all these things, right? So your node graph is basically going to look like a bunch of get custom variables, right? You're going to have like 1, 2, 3, 4, and then you're going to have to manage these, and you're going to have to add to them. You're going to have all this logic. You're going to do a bunch of checks, and that's really complicated and really tedious. It takes up a lot of time, and it makes your node graphs look way too complicated, right? When they don't have to be. Instead, what you can do is you can add a structure called enemy data. And in here, you can go ahead and add all of these. So for example, for prefab ID, right? I can select a prefab ID, add a new variable. I'm going to call it the same thing, prefab ID, and I'm not going to give it a value. I'm going to keep it at its default value because every entity is going to have its own prefab ID. And now I'm going to go ahead and add an integer. We're going to also call this kill reward. Again, I'm not going to touch it. I'm going to leave it alone. We're going to give it a string for its name, and then we're going to give it a floating point number. We're going to call the same thing, EXP on kill. And so now I have this enemy data structure where I have these 4 variables that I can assign on each entity. So let's go ahead and see how this works. I have to click on apply all for this to apply and work and get updated globally. So I'm going to click that. So now what I can do is I can actually delete all these 4 variables, and I can instead add a structure. And then when I go through my structures, I see here enemy data. I'm going to add the variable, and in here I'm going to put enemy data as the name of it. And in here, if I edit it, you can put all the values you want for that specific entity. So for prefab ID, I don't remember what it was, but I'll just do 1, 2, 3, 4, 5, right? Kill reward will be 2. The name will make it Bob. EXP on kill will make it like 12.2. And so now this hilichurl, and let's just say this was on a prefab, every prefab that is instantiated is going to have this custom data structure called enemy data, and it's going to have its own custom values which we can query in the node graphs. So same thing for this treasure hoarder. If I go ahead and just remove all of these different variables and instead add a structure, we're going to also select enemy data. We're going to add it, and if we edit it, you see that it also has all of these default values. And again, I can put in whatever prefab ID I need. The kill reward can be 2, his name can be Steve, XP on kill could be 100, and now we can customize every single entity's enemy data using this structure. Now in the node graph, I'm actually not going to change my entire node graph because it's going to take too much time out of the video. Instead, I'm going to show you how to access these structures in the node graph. So if we just type in structure here, you'll see that we have 3 nodes. We have modify structure, which can take a value from a structure and modify its value. So for example, if I go ahead and go to the enemy data, so let's just say I pass in an enemy data from one of the creations on my field. I can modify one of these. So for example, its name. I can change the name to something like, whatever, like Timmy. And then once this runs, it's going to change the data that's on the structure that's on the enemy. And then we have assemble structure, which literally just assembles a structure. You can create one inside the node graph. So again, I'm going to pick my enemy data template, and then I can put in whatever values I want in here, and then I can pass this into whatever accepts that structure. And lastly, we have split structure. Now this is actually kind of interesting. This is actually very useful. So split structure also takes in a structure, so in my case enemy data, and you see that it actually splits it up into their individual components. And this is what's so great, is that instead of having to get all these custom variables on an entity, I can instead get this structure, and it's going to split it up and give me access to all of these values independently. And then I can pass these into whatever node graphs I want. Now the cool thing here is, let's say in my example, right, I'm going to show you how I have something set up here. I have an item library structure. And this is a very, very long structure that has a lot of information in it. If we just go ahead and go through them here, you see that I have dictionaries, you see that I have lists. It's mainly just dictionaries and lists. But you can see here that, for example, I have these rarity tags, which I have orange item, purple item, blue item, and I just have it here as just kind of this something that I can reference whenever I need to, right? Similarly, with all the weapons in my game that have an orange rarity, I have all the weapon configuration IDs set right here that I can reference later. And you can see that the structure has all these pre-made, preset values. It's not something like my enemy data that has this default value and then it's just a template that I can edit in the node graphs. It actually contains data that I would like to reference without having to set it each time. So the cool thing about split structure is that the type of structure that it takes in, so for example, if I were to set this to item library, you see that all of these lists and items and dictionaries, actually they will all give out whatever default value you have in your structure. So you don't actually have to pass anything in here. Sword items will always give me all my sword items. Bow items will always give me my bow items, and rarity tags will always give me my rarity tags. That's what's so cool about this, is that I don't have to specifically get all of these lists individually. I don't have to get, like, for example, with custom variables, I don't have to have 18 custom variable get nodes in order for me to get all of these values. I can just use a split structure, and then I can specify what structure I want, and it's going to give me all the default values. So you can actually store information in a structure beforehand, which you can reference however many times you want in your node graphs. It's always going to give you this data. So as an example, just to kind of tie this all into the node graph, instead of having to query every single custom variable, right? Like let's say I had like all these 4 things where I had the name, the EXP, I would need 4 query custom variable nodes. Instead, what I can do is I can just have one, and I can pass in this enemy data. I can specify what the type is. So in our case, the type is a structure. It's a type of enemy data. And then here, you can go ahead and pass this into a split structure, which will take all the values inside our enemy data for that specific entity, for the hilichurl, let's say, and it's going to give you all these prefab IDs and the kill reward and whatever. So for the prefab ID, I can pass it here into the key, and for the kill reward, I can pass it here into the value. And let's say after the entity is destroyed, I want to give the player some XP. So I'm going to take the EXP on kill value, and I'm going to do some logic with it that will give the player XP based on whatever this value is, right? And so you can see that the possibilities here are pretty endless when it comes to structuring your systems and your data inside your game. It's so much easier to just get one variable and then have that one node that splits up all the values of the variable, which you can use in your node graphs.